Good afternoon, one and all. I am Udeshri, working as Assistant Professor in the Department of Mechanical Engineering in St. Peter's Engineering College. In today's class, let us learn how to make 2D cantilever beam stress analysis. So, before entering into the experiment, let me tell you the question. The question is conduct a stress analysis on a cantilever beam of cross section 100 mm by 100 mm length and 1000 mm, and tip load is 500 newtons. Young's modulus is 2.5 e to the power of 5 kilonewtons per mm square. Poisson's ratio is 0.3 and density is 7.83 e to the power of minus 6 kg per mm cube. Now let us start with the procedure. You first go to preferences, structural, H method, click OK. Next, preprocessor, element type, add, edit or delete. Go to add, beam, 2 node 188, click OK, close. Now, material properties, material models, structural, linear, elastic, isotropic. Now enter the values. 2.5 e to the power of 5. Poisson's ratio is 0.3. Click OK. Click on density. 7.83 e to the power of minus 6. Click OK. Now close it. Now go to sections. Go to beam. Go to common sections. So here some standard, that is the common sections which we use in beams will be available. So these are the common sections. So you can choose the type of section you want. So here, as I need a square beam, means the beam with square cross section, I'm choosing a square. So now what I'll do is I'll just enter the values of B and H. Similarly, if you're going for different types of beams, see for example, if I have some beam with I section, so here they'll ask you for different values, and all the means what is W1 indicates, what does W2 indicates, like this different values will be means it will ask you for entering different values, and all the terminologies will be mentioned on the figure. Now presently, as I need a square, I am clicking on square. Now let me enter the values of B and H. It's 100 and again 100. Okay, now go for preview, click OK. Okay, so after making the cross section, go to modeling, create key points in active coordinate system. Make the first point as 1, type 0, 0 and again 0. Click on apply. Type 2 means you are going to enter the values of point number 2 and the length is 1000 mm. Click OK. So like this you will get 2 points. After getting 2 points like this, see here is the first point and here is the second point. Go to lines, again to lines, select straight line, select the 2 points, click OK. Okay, then here is the meshing option. Go to meshing, mesh attributes, all lines, click OK. And again in the meshing, go to size controls. Here is the size control, manual size, go to lines, all lines. So here you decide how many number of parts you want to make your beam and how many number of parts each part should divide. It means if I am entering 10 and again, it means the beam will get divided into 100 parts. Okay, 10 by 10. Click OK. And now again go to mesh tools, click on mesh. Now here you have pick all option. So it means you have meshed the complete beam. Okay, now in preprocessor, go to loads. Here is the load, and in load, go to define loads, apply structural displacement on nodes. See, select the first node, means wherever, means as it is a cantilever beam, it will be fixed at one end and it will be free at another end. Click on the side where you want to fix it. So as I want to fix at the first point, I am clicking the first point. Click OK. Select all degrees of freedom and again click OK. So like this, you have fixed the one end. Now you can apply the load on other end. Now go to loads, go to force or moment. So here is the option, go to force or moment on nodes, select this point, click OK, and the direction is FY direction and the value here is minus 500. Okay, now click OK. So now you have applied the force in downwards direction. Now go to solution. Go to solution, solve, current LS, click OK. So you have to get the answer like this, like solution is done. Okay, it means whatever the process you have followed till now is right. Now click close and again close. Okay, now go to general post processor. Next, go to query results. Then go to element solution. Click OK. OK. Now in general post processor, go to plot results, counter plot, element solution. Now if you want to, means you have to check what type of values you want. So here you see you have different things like stress, elastic strain, plastic strain, creep. So like this you'll be having different things. You can choose whatever the one you want. If it is stress, you have again option of selecting what type of stress, like X component, Y component, what type of stress. Now let us click on X component of stress. So this is the deformation which you are getting on applying the load in X direction. So like this, similarly, whatever the different types of stresses you want to find out, you can find out using this option. Next, if you want to see how it is, how it looks in 3D view and how it looks when it is, when before it got deformed, so you can go for plot results. So this is how you get deformed shape here. We have few more options here. Results, counter plot, nodal solution. You can take any other thing like displacement vector sum, click OK. So this is how you get different values. The all maximum and minimum values will be represented here. So you will get all the values here. Next, plot results, counter plot, element solution. You can take anything. You can even take one meso stress. Click OK. So like this, whatever the values, whatever the maximum deformation you have, everything will be displayed here. So like this, it will change the values here. So here generally means when you see a colorful figure like this, the red color will indicate the maximum value and the blue color will indicate the minimum value of stress. That's all for today. Thank you.